What is going on, ladies and gentlemen? Yes, it is I, the Wild Martian, coming to you from my Windows machine. And today we are going to talk about why you should invest in at least one static language. Now you might ask yourself, why isn't the topic saying why I should invest in at least one dynamic language? Well, the reason being is because dynamic languages are already the most popular languages. And the reason that is because they're the easiest programming languages to learn. Yes, I did say that. If you go on the internet, you go on every website, you look for a list of programming languages that are the easiest to learn. You will find in that list, in the top 5, at least 1, 2, or 3 dynamic languages. You will definitely find Python. You will definitely find JavaScript. You might find Ruby. Also, you might find some HTML and CSS, but that's a conversation for another time, okay? And the reason these languages are so easy to learn is because there is less discipline involved to getting an output. So you can butcher your way to an output. But anyway, that doesn't matter. We are going to be using 3 examples. We have a JavaScript application, and we have a Python application, and we have a C# application. So JavaScript is a dynamic language, so is Python, both scripting languages. C# is a static language. It's a strongly typed programming language. Okay, so just to walk you through my application, what does it do? Okay, so there's an object called user. It calculates your ninja skills. Actually, it doesn't, it's just a thing. So it takes one parameter of skill, which is a number, and it multiplies your ninja skill by another ninja skill, another skill, I think, it doesn't matter. There's another one that adds 2 numbers, and it would just console log and console log. Same as a Python application, we have a dictionary. We've defined a function, and we just multiply by the ninja skill and return. Add 2 numbers and return, okay? And then we have the C# application. So we just have a public skill counter. We adding 2 numbers, all right? Now you will notice that I don't have the dictionary just yet here. I am yet to write it, but this is for a point that I'm gonna make. So the first point I'm gonna make about static languages is their code is easier to read, all right? So if you look at this function, using your own intuition, you could probably figure out what it's doing. Same goes for this function, and same goes for this function and this function, right? But this function could do something differently depending on the parameters you pass to it. For an example, I could not pass numbers, I could just pass strings. It would return 35 instead of 8. Same goes with this ninja skill, right? So in a sense, you could tell about the intuition, your intuition, but you might have to go deeper inside the function to actually be sure that it is doing exactly what you think it is doing, or what the definition of it says it's doing. Now, if you flip over to this one, right, you have an accessor, you have a return type, you have the name of the function, you have parameters which are typed to something, right? Judging from the definition of this function, just by looking at the definition of the function, it tells you exactly what the function is, what it's doing, and what it will return, and what type it will be that it will return. So you don't have to go deeper into the function to see what it's doing or to expect certain things of it. For an example, this function will never return a string. This function will always return an integer because that's the definition of it. Second point is this. Static languages or strongly typed languages are strict, and they enforce discipline on developers and the code they write. For an example, I'll do something here. All right, so I have defined a dictionary which will have a key of string and a value of string, okay? So suppose I wanted to use this dictionary, right? If I were to do something like this, As you can see, I don't have an IntelliSense for a user. And why is that? Well, the reason being is because this is a static language and this dictionary isn't declared static. Hence, it cannot be used in this context, okay? However, if I do make it a static and say ninja skill is 24, all right? Now I'm getting an error here that says source type int cannot convert source type int to target type string. I'm trying to do something similar to this, right? So it's saying you have defined a dictionary that will have a key of string and that will have a value of a string. And this is not a string. It is in fact a number. So I can do something like this. And when I want to use this value as a number, I have to convert it to a number. An example is, so if I return my skill, as I did here, I multiply my ninja skill by the skill passed as a parameter. So ninja skill multiplied by the skill. Okay, now I have to pass this into an integer. Okay, so now you have a valid function. So you ensuring that the ninja skill is in fact an integer before multiplying it with the skill. This is what I mean. It forces you to be strict and it teaches you discipline, right? You do not just declare things out of nowhere and use them however you want. There's a structure before things are used. Okay, another point regarding static languages is they are slightly more faster than dynamic languages because a lot of things are decided beforehand. A lot of weight is put on the developer, unlike in dynamic languages where the language itself does a lot for you, and that kind of like cuts down on your performance as well. For an example, the type of this variable is decided when the code runs. So when the code runs, the type of this variable will be decided, right? Right now, it is unknown, and this variable can change to many different things. For an example, in Python, you can't do something like this, add a number to a string. app.py, and that's what returns. So if we change the 3 to a string, we should get an error. Let me just change the color of this to green. So if we run app.py, we should get an error. And we do get an error saying, so you have a string and then you have integer, and you're trying to concatenate. So that is not going to happen, right? But what if we did something like this? We create a condition making sure that this function, this line of code never runs. What will that do? Will that still break the program? Okay, so now what we're saying is if 0, which is if false, actually let's say if 1. So we're saying if this condition is true, run this piece of code, else run this piece of code. So num2 is 2. So in a sense, we'll be adding a 2 to a 2, right? Let's run this. And the code did not break. The reason it did not break is because this line of code is actually valid. So you're adding a 2 of num2 plus 2. So when the execution of this is saying if 1, which is if true, which is true, it's going to run this block of code, and then it's going to get out without ever looking at this and without ever touching it. So this line of code is valid, and this is the line that gets executed. However, this one is not valid. it would break the function if you were to change this to a 0, right? But as long as this doesn't run, the execution is fine. If you change the condition, you get an error. And the last point to this is most dynamic languages are interpreted languages. Python is an interpreted language. Ruby is an interpreted language. Well, most of them. JavaScript is just-in-time compiled languages, not interpreted. Okay, so that's why they are so easy to learn, because they're written to the highest of levels. Basically, I sort of feel like interpreted languages are where languages made to achieve just one specific task, to automate certain tasks. For an example, let's say you were a data scientist. You wouldn't really care about the type of programming language that you are using to sort of run through your data, produce results, produce visuals and graphs to present to your team. No one would ask, what language did you use to write this? It seems it's a little bit slower. No one really cares about that. So it's sort of like it's a tool for just achieving a task, right? Whereas if you talk about static languages, it feels like static languages where people said, okay, guys, we're going to build a massive system. We're going to build a financial system. We need a programming language that is very rigid, that follows a certain discipline, which people could be guided to and learn it. And they would write code that is easier to look at and understand, and ensure that in the future, when someone looks at this code, they will be able to understand what it's doing and how it's doing it. And whilst doing that, we also keep performance in mind. So in this type of scenario, you are going to go back to the code and see what it's doing to change things even in 10 years. But then, someone decided and said, hey, guys, I actually like how Ruby is making me do things so simple for me. Let's put a framework on it and call it Ruby on Rails, and let's try to build massive systems with it and see what that's going to do. Okay, and the final word is, right, static languages take you spend a lot of time writing code structure and ensuring a real guideline that people could look at to a product, right? So to an output. So it takes a little bit of time to get to an output, unlike in dynamic languages where you get to an output quicker. But in doing that, you butcher your way into it, right? But there is a variable or there is a type in some static languages, C# specific, and it's called a dynamic type. A dynamic type allows you to basically put any type on a variable. On your dictionary, you can have this bit dynamic and this bit dynamic. If you really wanted that ninja skill to be a number, then you could do something like that. Then it would be a number. Then you'd be able to handle that. Now, this is not something that static developers generally do. This is not something we do. Like, you actually go out of your way to find things such as these, right? But if you wanted to do that, you would be able to do it. I am done. I hope you enjoyed this, and this is why I think you guys need to look at it, at least one static language. Just look at it, see what it's doing, and try it out. You might really like it. Honestly, you might really like it. Cool. Hope you enjoy this, and I hope you learned something. Peace out.